properties of each. Okay, so first of all, a kite is defined as a quadrilateral with exactly two distinct pairs of consecutive congruent sides. So the best way to think of a kite is think back to your elementary days. And what did a kite look like back then? The old-fashioned kites looked like this. And what do you know about them? They have two sides that are the same. And then you have two other sides here that are the same. Now a little bit about terms. We need to understand that the top angle and bottom angle, because I think about that kite visually back from my younger years. Okay, we call the top and the bottom angles the vertex angles. And then we call the other two angles the non-vertex angles. So think to a very basic kite when you think of what it looks like. And so first of all, real quick, we're just going to go through these today, okay? Because this is one of those things that I really think instead of maybe going through the investigation, you're already going to know. So I want you to think about a kite, and I want you to think about those non-vertex angles. So if you look at your kite that you drew, and you look at the non-vertex angles, if you just look at those, what do you think, or what do you notice about those? The non-vertex angles. They're opposite of each other. What else about the non-vertex angles?
They have two different sides going from them.
Okay, they have two different sides going from them. What else? Yeah. They're congruent. Okay? Because essentially, if you think back to the kite of your younger years, it was symmetrical. It was one of those you could fold straight down the middle. And in fact, some of them, even today, what they do is they put braces in a T. Okay? I know at least Tara's. She has like a stick that goes down the middle and then a stick that kind of goes across, and it makes a T, and then that's how the kite works. Gives it support. All right, so let's think about the diagonals of a kite, since I kind of already led you into that. Okay, the diagonals of a kite. What do you think about those diagonals?
They are congruent.
I don't know about congruent. Yeah. They're perpendicular because I gave it away. I said that they looked like a what? T. That's right. So the diagonals of a kite are perpendicular. They will always meet at a 90-degree angle. Always. So questions about that? Non-vertex angles are congruent. File that away. Diagonals are perpendicular. File that away. Okay, the diagonal connecting the vertex angles is the, that's a good question. The diagonal connecting the vertex angles of a kite is the perpendicular bisector of the other diagonal. Okay, so there's your kite. Here's the diagonal that connects the vertex angles, right? So if you compare that to the other diagonal, first of all, we know it meets at a 90-degree angle. We also know that that blue diagonal cuts those into equal parts. And that should make sense because remember what I said about the kite. It is symmetrical. You can cut it right down the middle. So let's look at the next statement. The vertex angles of a kite So the vertex angles are bisected by a diagonal. So essentially, what that tells you is that those two are the same, and these two are the same. And in order to prove those being congruent, we can use one of those triangle congruence conjectures. Your angle, side angle, and those, your side angle. We can go through and show a proof for that. In fact, I think we actually will do that eventually. Okay, so let's go ahead and look at the next slide, because this is what you're going to have similar on your homework. They tell you that you have a kite. How do I know it's a kite? Because of my labels here. I see that those two are the same. These two are the same. They tell me the perimeter is 1/16. So I need to find x. So basically, the easiest way to do this is to just label all the sides. What's the length of this side right here? 28. What's the length of this side here? X. So I'm going to write an equation. My equation is going to be 28 plus 28 plus x, and that will equal 1/16. So 28 and 28 is 56. X and x gives me 2x. Now you subtract 56 from both sides. So what does 2x equal? 60. So what does that leave me with x to be? 30. Nice job. Now you might not need to write the equation out. You might be able to look and figure it out that way. That's fine, but this is how you could use an equation. So, skip. Now we're going to talk about trapezoids. Trapezoid, you should have a definition of trapezoid down somewhere. If you don't, you might want to get this down. It is a quadrilateral with exactly one pair of parallel sides. And then you probably want to get the diagram down. Okay, I'll let you get that down. We'll talk about some conjectures. We'll have an example, and then we'll be done for today. All right, so once again, this is one of those times when you could probably just look at the diagram and we could figure out what the answers to the conjectures are. So I'll let you get some of those down and then we will talk about Okay, so let's look at kind of what I've drawn up there in purple. The bases, in this case, are the top and the bottom, correct? And I know that the bases are parallel to each other. So now I need to think, when it says the consecutive angles, so it would mean like this pair right here, and then this pair right here. So I need to come up with what in fact those angles are. First of all, are they the same? No, they're not the same. We can just visually see that. Let's think about that. What do we think maybe they might be? Yeah. Supplementary. They add to 180 degrees. The reason why that's the case is when we learned about parallel lines. Okay? If they're on the same side, those are same side interior angles. And same side interior angles are supplementary. That means they add to 180 degrees. Now, an isosceles trapezoid is like some of those desks that you see or those tables that you see. And basically, an isosceles trapezoid means those two sides are the same. And so when it talks about the base angles, it means those angles, because those are a pair, and then the upper angles are a pair. What do you know about those, or what do you think about those? What do you think about those two angles? They're equal. They're congruent. Now with that in mind, we're going to look at the diagonals. What do you think is the case with the diagonals in an isosceles trapezoid? They're congruent as well. Okay, those are the same length. So if they tell you it's an isosceles trapezoid, that tells you a whole bunch of things. Okay. Let's go ahead and look at an example here. We need to find what x and y are. Yes? Okay, just.
Oh.
So now real quick, this is a trapezoid, but it's also an isosceles trapezoid. The reason why I know that is because these sides are the same. So since it's an isosceles trapezoid, remember it tells me certain things. One of those things is that base angles are the same. So if this is 56, then y has to be 56. Okay. Now what can you tell me about this angle and this angle? They're supplementary. Those are those consecutive angles. Supplementary angles add to 180. So I need to just take 180 minus 56, and that will give me what x is. What does x have to be? 124. So that's the thought process you're going to probably need to go through when you solve some of these. Okay, so your assignment, and we will actually check this assignment Friday. Okay, on pages 271 through 272, I need you to do 1 through 12, not number 10. Okay, so pages 271, 272, numbers 1 through 12, not number 10.